Welcome to Ask and Learn.
Hi all, Alex B here with another question on electric power from Chapter 25 of Giancali's Physics for Scientists and Engineers. So this question tells us that we have an electric heater drawing 15 amps on a 120 volt line, which is plugged into an extension cord formed from two wires, each 2.7 meters in length and 0.129 centimeters in diameter. And it asks us to calculate how much power is dissipated in this extension cord. So first we're going to need to think for a second. We know that there's 15 amps flowing through the circuit, and we know that since the circuit is closed, that the amount of current must be conserved, and so we know there's 15 amps flowing through this cord. And we know that the cord is going to have some sort of a resistance, so we can calculate the power dissipated, P, using our equation which uses I and R. In particular, P is equal to I squared R. Now, to calculate what R is, we know that R is equal to rho times L over A. Using numbers that they gave us, we know that the current is 15 amps. We know from the book that resistivity of copper is 1.68 times 10 to the minus 8 ohms times meters. The length L is going to be 2.7 meters, but we know that we have two cords. We have one that's coming out of the wall, taking the current from the wall to the heater, and one going back into the wall, so we actually need to multiply this by 2. The area, A, is given by pi times the diameter over 2 squared, and the diameter is given to us as 0.00129 meters divided by 2 squared. Here I've put it in meters rather than centimeters, that way we don't mess up our units. Plugging in all of this, we should find that our power P is equal to 15 squared times 1.68 times 10 to the minus 8 times 2 times 2.7 divided by pi times 0.00129 divided by 2 squared. And after plugging in all these numbers, we should find that the power dissipated is about 16 watts. Or here I'm using two significant figures because that's the number used in the problem.